Okay, School of Tomorrow, friends. What I'm going to do today is talk about the hexapent structure, the ball that we keep talking about. This would be a hexapent, a soccer ball would be a hexapent. Some topics we've talked about are, well, of course, then there's virology has some hexapents. It's found everywhere in nature, right? Buckminster fullerene, of course, is an access point. And civilization itself, I was thinking back in 2016, this is my thinking globally in 2016 of September 2016. So this is like, what, 4 years old now. The game Civilization is due, a new version. And games already, computer games I'm talking about, and just games even before computers on boards, and they still exist. Those often have an hexagonal tiling pattern, right? You want your pieces to be able to move from cell to cell on a kind of a hexagonal tiling. And when you wrap that around to a globe, you get something like the above. Now, how can you get something like that on your computer, and how might you tweet it out to the world? This is something I've taken up in the past, and I actually had to dust off my skills quite literally. Let's do place-based and start here in the neighborhood. This is the next to the Linus Pauling house. One door, 2 doors down is this for sale property, and over time we've watched it gather layers of street art, we can call it, and going in the direction of the future. Let's see what we got here. Is this the future? Okay, yeah. Here's my Raspberry Pi. Now, this is a very appropriate technology. By the way, the Pi is just this tiny, tiny little circuit board right here. What you see, oh, actually, that's the one I'm not using, but that's what it looks like. That's a Raspberry Pi, and then there's another one actually protected inside this case, which you can see all the wires coming out, but you also maybe can't see, but there's all kinds of like spider webs and probably worse growing here. I'm going to get down there with I don't have a dust buster anymore, remember those? But I'm going to go down there with just a vacuum cleaner and clean this up a little bit. I haven't been spending time down there. It's in a rather basementy basement. I mean, I've seen many basements. It could be worse. But you know what? That's why we have this VNC server installed. I have very nice Tibetan prayer flags down there. Totally protected from the weather, whereas the ones outside are completely bleached. And I happened to run into the owner of the Tibetan prayer flag store at Fred Meyer's yesterday as we were both buying seafood. We talked about it. It's tough to get his business right now because he's doing mostly mail order. So here we go again, the Raspberry Pi. But why is it so relevant, the Raspberry Pi? Because it too is a hexapen. I'm talking about the logo itself. Count the little berries or little nodes on the berry. What do you call those bumps on the berry? Count the bumps. How many around another bump? Like you should be able to find 6 around one and 5 around one, both patterns on your Raspberry Pi. So that gives you some context. The old furnace, hideaway bed, there's the flags. Leela used to live down here at one point. That was back in the rock star days. Carol's crashed out there in that picture. So I guess that's enough Raspberry Pi. This is going up my steps to where I am currently in the video studio. This is my dad on the left. This is a picture that's come up in many of my YouTubes. He's there working with his team on the future of Libya, right? Zoning and stuff like that. So I think we might come into my office, but I deleted that picture. Well, there it is. That's not deleted. That's what my messy office looks like at the moment. I'm sitting over here, and I've got Barry the Python is behind Zohar's head. Zohar is this guy. You've seen him in earlier YouTubes. And behind him it's kind of like Mr. Rogers' Neighborhood or something. Barry the Snake, who's featured also in this photo stream and in my YouTube channel, and there's the garden. The C60 Garden, right? Made of, this guy's hollow. This is a 3-frequency cube octahedron made of C60 balls, but there's no inner layers, right? So it's just the 92 balls. And then I have just the 42 balls over here. Lucky faculty get to come camp here and play with this stuff. There's a supply of extra balls, but of course these are times of very low visitation rates for obvious reasons. See, there's the old prayer flags. I've taken most of them down. I've thrown them actually in this bin over on the left. I might do a burning ceremony, and of course the American flag also spreading the teachings, we could say, in our transcendentalist vein, right? Which links forward through, as I was saying, to like Alan Watts, through Aldous Huxley and modern contemporary Buddhist thinking also, which Harold Bloom was not so fond of. So there's lots of forks in the road here. The other thing, though, I want you to think of these tiles in a hexapent as being heavy. Think of this as planet size just for fun, and think of it as completely hollow. There's been a lot of hollow planet sort of mythologies over time. Don't worry, I'm not going to try to make you believe in any of that, but I do want you to think in terms of hollow yet held together by gravity hexapents as a mental exercise. And then we're going to wind up kind of on that topic for now. So here's two panels of C60. One reason it's called that is because it takes exactly six of these panels, and they're very intricate on the inside with ribbing for reinforcement, but also slotting. So when you slot these together, it's quite unambiguous how it has to go, the C60. So exactly 60 of these panels, and you get a ball like this. And then there are these screws that help it hold together. And what about we just use gravity? Now, if you're in a 0G simulation, in other words, there's no ambient gravity, but then the blocks that you introduce, the hexagons and pentagons shown below, think of it as a puzzle. Think of a computer game where you think of these hexagons and pentagons. You could think of them as magnetized, but let's think of them as only gravitationally endowed. And you might say, well, they would never come together then. They're such a weak force, gravity. But I'm thinking make gravity as strong as you want by just making them all heavier. Because we're not, make them as heavy as you need to have some appreciable gravitational force. They're all made out of iron at least. Let's go heavier. Pure gold, let's say. All of them are pure gold, okay? And, they're each huge. They're the size, this is the size of the moon here, let's say. So would that be enough gravity? I think in the absence of any perturbing forces, in other words, without anything to pull it apart, I think the gravity there would be, even if weak, these things would clop together. They wouldn't want to separate. And the closer they are, the stronger the force going up as a second power, till finally they lock together, and it's kind of like beveled. It's kind of like an arch. Once they're like this, it's like they all want to fall in further. They all want to collapse towards the center, common center. But because they're all beveled and compressive gold plates, they can't go further in. So they're being compressed now. And if you weren't convinced about the power of the gravity to hold them together across these fences around each territory, put a stake in the center of each one of these hexagons and 12 pentagons and do a fish line or other tensile strong cord between neighboring pegs or poles and just tighten it. Tighten it as tight as you need to tighten it. And then you'll see, yet we cannot go further in because these plates made of metal and so on don't want to compress any further. So it's like an arch again. We can't compress any further, even though we keep tensing and tensing, right? Make it very, very hard to pry these apart once you've really tensed it. Now that could be a toy. You could sell what I just described in terms of plastic hexapent with things that you tighten on the outside. It could be a more serious, not toy design. So that's another interesting artifact. Another artifact, by the way, that you'll wonder about once you get into this. Let me show you the Raspberry Pi though. I've got it on VPN. The reason I don't have to go into the basement all the time is because here on my desktop there's a hexapen I just made before doing this video. But there was a lot of prep work years ago before I could have done even just like this. What is the prep work I'm talking about? I've been leaving the Pi all this time running in the background, upgrading. I haven't upgraded this thing in years, so it just cranked through this amazing upgrade session. But what we're looking at is that Pi in the basement, right, that I started out with. And we're looking at its command line, which is a Linux, and it's running on an ARM chip, or you could say. If you don't know what ARM is, I've got some blog posts, but there's a lot more information out there on YouTube. So here's a trailhead. Lots going on in the economy around ARM. So that's what I just did, is a sudo apt-get upgrade. But before that, let's go a couple back. Here's how I got the hexagon. There's the command line you need. Let's get this bigger here. Let's make this wider. So again, this is a VPN. I'm upstairs 2 floors up talking to my Raspberry Pi in the basement and trying to make everything very visible. Now it's quite a trick to be able to mess with the command line window. I'm using the GUI on the Pi. So this is the Pi's GUI, and I'm just trying to make this thing wider so you can see better what I'm doing. Okay, scroll back up. You might see references to programs you've heard of. Here's GCC, compiler, Bash is being upgraded, all kinds of stuff. But what I'm trying to get up to, oh, I know what I was doing. I was using my arrow up command. That's much smarter, Kirby. Don't scroll up, arrow up. So arrow down, and now arrow up. We'll see the whole command this time. There we go. So I wanted 768 by 1024 bits, height and width. Turn on anti-aliasing. That slows it down but makes everything look a lot better. This isn't actually POSIX, really. This using of plus signs and so forth is a little bit non-standard of the POV-Ray, right? They're not using the exact format for switches that are specified as, you know, conventional in this kind of command line environment. Nevertheless, it works as advertised. So that was my last step. But how did I get a Hexa 1 to begin with? That's interesting. What Adrian provides is an ability to get the reciprocal of a polyhedron stored in off format, which is a quite simple format that it would really be good to dive into at some point. I won't do it right now, but it's very, very intuitive format for storing polyhedrons that is kind of also a standard. And what Adrian has provided, Adrian Rossiter, is a utility here that will suck in a polyhedron in .off format and output its reciprocal, meaning its dual, meaning every face center becomes a vertex, and every former vertex becomes a face center, and the edges kind of just rotate in place at 90 degrees. You can think of it that way. That's taking the dual of a polyhedron. Very clever. Very clever. So the beginning of this whole thing is you start with, let's see, where is it? I floundered about, you know, it's been so long, I've forgotten all the command line stuff. I forgot where everything was on the Pi. So I really spent a lot of time messing around before I made this video, but now I'm going to go back and try to find where did I get started with that geodesic ball in the first place. Here we go. Geodesic ball. So frequency should be 6, and we should make it an icosahedron and spit out this here ball, icosahedron class 1. So this is all kind of like geodesic dome and sphere jargon. And okay, so Adrian's program, let's take a look where that is. I'm going to go back to my regular browser. Here's an example of a command. There's that dual command, and it's a lot more complicated than I was showing because I just used the basics, right? There's geodesic, what we started with. I was going backwards in time, so we got to this last, but this is where it really actually starts, in that I create a ball of n frequency as an omnitriangulated geodesic sphere. So if we look in examples, for example, if we look in albums, I should say, and scroll down to his geodesic spheres section, where are they? Isn't there a whole section on those? Scrapbook? There's a bunch. So here's like geodesic icosahedral. That's like what I start with. But then you want to turn every face center, so each one of those triangles, into a vertex. And it turns out that you therefore get around an existing vertex, which will turn into a face center, you will get a hexagon. Each one of these triangles will give you the corner of a hexagon. And so that's why, back to the Raspberry Pi, that's why the final result is a hexapent like this. And there was a time when I was doing these on the Pi and tweeting them out and being happy about it and being boastful and writing it up on EduSig back in 2016 again. But I wouldn't mind resurrecting this campaign, which we could call Blowing Bubbles. This is the old archives before they converted it to Mailman 3. I like the plain text, honestly. I think this was a better format in terms of just trying to share source code. People don't know how to use Markdown yet. Maybe it's a good decision, but to upgrade, I'm not so sure. So here's Pavre on the Pi, August 25th, 2016. So we're going back 4 years and talking about this whole process I'm just kind of showing you now, and some example tweets that I did in my channel. As I told you, I do use Twitter. I just don't consider myself an advice giver on how you might want to use Twitter, even though I dispense advice left and right. Like, I'm always giving advice. I don't do so on every topic. Okay, so I think that pretty much covers it for now. It's that thought experiment I want you to keep thinking about. Getting the tiles of a hexapent to close and adhere against each other gravitationally. It's the hollow gravity meme, and I think that's important for synergetics. And as I'll summarize, with synergetics, if you've been watching these videos, I think I've successfully parked it in the American philosophy department, and it's radiating out towards transcendentalism. We've got a lot of literary connections. We've got the Ezra Pound connection through Hugh Kenner, stuff like that. And then we're dividing out, we're taking out of synergetics. The concentric hierarchy is kind of the beating heart of synergetics. And while we have synergetics itself parked in American literature, waiting for people to catch up, realize it's not just popularized physics and therefore stale, it's something else. Let's take the concentric hierarchy and put that in a math track at the high school level, at the core of what I've been calling lambda calculus, so that we keep the right brain alive with polyhedrons and we kind of have an even playing field, a new content layer. It's not like we're abandoning anything we've ever done. We are just putting some new emphasis on something new and novel, and also connects to a positive futurism for a change. So there's some built-in sort of upbeat about the future thinking that we don't have to reinvent the whole wheel there. We can just start with that. We can start with a new civilization. All right, talk to you soon.